Well, welcome back. We're finally to the point where we're going to have to fix this little deal here, the little dial needle for our little radio. Now, I've been spending the last couple hours going through the schematic. By the way, we're still experiencing a speaker rattle. And I've been taking voltage readings at all the different places, and we're not having a whole lot of luck. I will say that right in the middle, let me get a pencil here. Right in the middle, it is not the speaker, guys. I changed speakers on this thing, rewired it to a different speaker, and this, the problem is still there. Now, right here from the volume control, we have the garble right there. So we know everything over here is good. It's coming from somewhere in this area over here, to where it gets to the volume control. So I'm still checking voltages and stuff like that. I've had this problem in the past. This rattly speaker turned out to be a voltage problem on the plates. Just not quite enough voltage to drive the speaker. So we're working at it bit by bit, slowly. It gives me something to do. You know what I mean? All right, back to our little needle here. The question, I asked everybody, what ideas do you have for doing this? I had my idea. I pretty much knew how I was going to do it. I just want to see what kind of inputs I'd get. It's always good to solicit different opinions. My opinion is not always the best. However, I got some that were pretty cool. I got, somebody said drill holes in it. No, that's not going to happen. One said take a car battery and fashion a spot welder out of it and spot weld it on. I don't think I want to do that either. And then, of course, our old buddy Buzz up there in Oregon, he wanted me to take a blowtorch to it. Oh, yeah, I'm going to take a blowtorch to it, Buzz. I think what he meant was take like a Bernzomatic and heat it up, flow to solder. I think that's what he meant, but he called it a blowtorch. Most of you had pretty much the right idea, by epoxying this thing onto here. Now, one good thing about this, and I didn't discover it until after I ended the video, this needle does not go. Let me zoom in here now. This needle, the little thin needle, does not attach to the larger part. If you get it right in my fingers here, it's kind of tiny. Okay, it does not attach like that. And the needle come up like that. That's not the way it's done. I discovered that it actually attaches on the rear, which is even better. It does it like this. See, now this, boy, it's hard handling this little thing one-handed. This little thing actually attaches to the rear and drapes over the back and then goes up this way, okay? From the back, this top part, it comes down, goes up underneath this thing here, and sticks up that way. So, now that we figured out how to do that, how do we hold everything still and get that thing done? Because what we're going to do is try soldering it first, and if that does not work, then we're going to do what a lot of you suggested. Go ahead and epoxy this thing, which is no problem. Either way, it's going to stay on there. We're going to fix it. We always fix it, okay? All right, now my question is, how do I hold it in place? Man, it's going to do it, like wrap strings around it and tie it. Use super glue to temporarily hold it and then break it off and then clean the super glue off. Well, I think there's a better way. We're going to use a magnet to hold it in place. And then this thing here will be positioned right up on top of that larger part. And then I'm going to tape it off on the bottom down here to hold it in place. Now, before we do that, of course, we want to flow a little solder down the center area of this large part. We're going to take some flux and flow a little solder down there. And then we're going to put a little solder on the underside of the needle itself. And we're going to flow, put some flux on there and flow a little solder on it. Then we're going to put it back in this position right here. And then just heat the needle until they both melt and flow together. And then we'll take the iron off. At least that's the theory, okay? First thing I have to do is get the flux on the large part. So let me get this thing set up. Now, some of you don't know what flux is. Well, it's an acid. It's a type of acid they use in soldering. There's all different kinds of acids they use for welding and soldering and brazing and a bunch of other crap. You know, plumbing work, that sort of thing, for copper or whatnot. I use the general purpose flux. I get it at Lowe's. Comes in this container has lasted me forever. And all I do is take, you know, something small like a pencil or a little tiny screwdriver and apply it to what I need to have. You know, you can take a brush normally, like a little acid brush. That's where the term acid brush comes in. They dip it in there and then they paint it around the copper, you know, before they heat the copper and sweat the two pieces of pipe together. Anyway, I took a little bit on my little pencil here and I put it down the center of that piece of metal. See it? Nice glob of it. Because what I want to do is I want to heat that up, and that it will transfer heat better. I've already sandpapered, by the way, the metal. I sandpapered the metal here, and I also sandpapered the bottom of the needle. If I can get it over here. Let me see, where is it here? Come on, baby, where are you? Okay, I've soldered. Yeah, I've sandpapered the bottom of the needle. See where it's shiny right there? Those are the two surfaces we'll be soldering together. You got to make sure they're nice and clean, okay? And I'll put the flux on the needle too, so when it comes time to solder it. So what I'm going to do right now is just heat that with an iron, and that stuff will all kind of melt and bubble and everything. Then I'm going to take some solder, just like this. I'm just going to flow it right on there, like just a little line of it, okay? And if it doesn't turn out to be exactly in the center, so what? Well, there we go. We have cleaned up the boiled flux that boiled around. This solder just kind of flowed all over the back of it when I hit it with the iron. That, you know, that's to be expected when you have flux. It's just going to go wherever the flux takes it. And but we have it tinned on the underside of the needle, and we have it tinned on the top side. I've applied a fresh layer of flux. Now I'm just going to take the soldering iron, just like this pencil. I'm going to press it down against the needle, and it should melt and fuse the two together. Let's see if I can pull that one off. Well, there she is. Not the neatest job in the world. I just got done cleaning all the flux off it, but it is strong and it should hold till the cows come home. Now when I put it on the radio, it's about centered up pretty darn good, I think. Now when I get it back on the radio, of course it'll go back in this way. Okay, the string will go, the dowel string will go between those three tabs, just to the top of my finger there. And then this thing will stick up and go back and forth. Now I may have to do a little adjusting, maybe a slight bend here and there to get it right, but this time I don't think she'll snap off with the slightest catch on a towel. But anyway, let's consider that one more job fixed. Now let's find out what else I can break this week. It's about 10:30 at night. I got home from work a little while ago, walked the dog, and there's a package waiting for me. I've been expecting it. Brendan said I needed one of these, so I went ahead and bought one. I knew I needed one. I just didn't want to spend the money all these years because they really want some big duckies for these things. I thought they were always overpriced. So, you know, it's a matter of principle with me. I don't mind spending money, but I'm not going to be ripped off either. Anyway, old Brendan, he bought two of them. I said, well, that's fine, Dandy. He researched it. He found it. So let's find out what it is. Now, we're going to use this, by the way, with the airline when we get back to it. Alright, let's see what we got here. Okay, it's all taped up. Let me get it untaped. It's a Cornell Dublier Electronics Decade Resistor Box. 2 watts. These are 2 watt precision, 1% precision. And it goes up to 1 million ohms. It's 1,000 times 1,000 K. 1,000 times 1,000 is 1,000,000. And I'm going to be opening it up here probably in the next day or so. Let me see if it looks like it might have been opened up in the past. No. Apparently this guy, it's J.R. Loy Enterprises is the name of the eBay seller. He wrapped it very well and he shipped it right away, and the price was great. $15 for that. $15 for that. And some of them I looked up they weren't even as good as this, and they ran 150, 160 bucks. That's why I never bothered with them. It's just, this is crazy to pay that kind of money. Even the old Heath kit Decade resistor boxes were overpriced. Insane prices. You know, if you see an insane price, don't buy it. The heck with it. Cornell Doublier, and on the back, this gives you all of the resistances. 5% down to 1%. And I think these are all 2-watt resistors. Let me see here. Yeah, 2-watt resistance, 2 watts maximum. I think that's, so that tells me they're 2 watts inside. This is really nice. This came out of some school somewhere. These are very nice, very good condition. It was made in, let's see, I think they've got the date here. There it is. Tested 1 November 1978. Tested by a guy whose initials were GB. Well, there you go, GB, if you're still hanging around there. Well, it looks like once again we have a case of magic. I love magic in electronic gear. And by that I mean it magically fixes itself. Don't ask me how. Here, you know, I've been working on it, tracing it down using this signal tracer that we put that grid leak resistor in a while back per Mr. Carlson's lab instructions on how to do it. Remember that? I figured it'd be a good chance for me to get it out and see if it actually works. I haven't done that yet. So anyway, here's what we have now. I'm probing around, checking around, moving things and everything, and all of a sudden, you know.
Because they built their team, one around their quarterback, where you have 2 stud wide
Can you believe that?
Darius Thomas and Emmanuel Sanders. You've got a running back. You've solidified your offensive line. You've got your team built. That's the problem with the Browns.
Crank it
Everyone
way
keeps
up.
pointing to the quarterback. The unfortunate part is this is a team who had, what, 13 drafts?
Well, it looks like the old speaker rattle disappeared. Now, of course, when I get it home, put it in the case, turn it back on, it'll probably come back. That's just the way it is. But right now, it's perfect.
Come in, and they have this mass exodus of older players they let go. You know, cutting a guy like
All right, now I'll tell you what. Let's go ahead and just take the signal tracer. Now, I've got the negative lead of the signal tracer probe. There's the lead coming out of the bottom of the probe. I've got it connected to the negative side of the capacitors, the filter caps. And the reason I'm doing that is just because this is a floating ground, and I know that the negative side of the filter caps would be connected to that floating ground, so that's what I might as well just connect it there and get it over with. Now we can go ahead and take our probe. Let's see if it'll work. Now I'm just going to do it once. I'm going to show you the wiper of the volume control. Here we go. I'm just going to touch that center connector. Let's go ahead and turn up the volume a little bit.
being able to be effective for the Browns is Hugh Jackson. He's going to work to his strengths. He's going to do things that I think
perfect,
allow him to be effective, and he's going to protect them. I don't think he's going to subject them to.
I'll tell you what, I'm real happy about that.
Really plagued our D3's career thus far. So I think there's some optimism and hope.
All right, I think what we're going to do is we're going to call this thing fixed right now. I'll have to put, of course, the dial scale back on and all that jazz, but there's something else I want to cover that I made a mistake, a little error in the last video, and of course all of the I Gotcha crowd came sliming out from under their rocks to tell me all about it and trying to suck me into a big argument and discussion. Not going to happen, so let me talk to you about that next. In the last video, you know, as I was talking, my mind was racing ahead about what I wanted to say and how I wanted to position the wires and position the pencil. You know how it is when you're making videos, it doesn't quite go as smoothly as you want it to do. The original plan for this was to solder here and then wrap it around pin number 1. But what I did was the opposite. Now I wrapped it around pin number 2 and then, you know, used pin number 1, which is connected to nothing inside the tube. It's just a piece of metal hanging there. And I hooked all the wires to it and then used the jumper between, which was the intent of the entire video. It wasn't to show anybody, well, this is number 2 and this is number 1. It's to show a jumper and how to do a workaround if you have this problem and you don't have a lot of money, you know, to buy a new tube socket, you don't have time or the inclination. You can still get the radio working again, if only temporarily, okay, to do further troubleshooting or whatever. But, you know, I was, for some reason, I was still thinking that this was pin 1 here, and I was going to wrap it around this one. I don't know how that happened, but you know, when you're making videos, like I said, sometimes things just don't go smoothly. And of course, you know, people jump out and they want to make a big deal about a minutia, absolute minutia. This here, pin 1, is connected to nothing. You know, I could have snipped that tube pin off. It would have made no difference. And I could have gone ahead and used this as a, you know, a terminal point. I was kind of surprised that it hadn't already been used by people at the factory. You'll run into this a lot. Folks at the factory will have a particular tube pin that has nothing on it. It's just connected to nothing. And they'll say, hey, you know, we'll go ahead and use that as a terminal. They'll come in with a wire and run out with a wire. They'll come in with maybe 2 wires and run out with 2, you know, depending on how they want to do it. So sometimes you will see that. And that's all I wanted to show, you know. I mean, it wasn't, you know, pin 1 or 2, it just wasn't worth a big deal if I made a little mistake. But, you know, it's going to happen. I've told you guys 1,000 times I'm not a perfect person. Yeah, I'll never be a perfect person. Too bad, so sad. But there is one other thing I do want to show you. Now right here, between pins 1 and 2 is where we put our jumper on the bottom of that tube socket. But let's suppose that pin 1 had, you know, already had something soldered to it. They had already used it as a terminal, you know, point to solder wires to, and there would have been no loose terminal available to do that jumper on the bottom of this socket. What could we have done? Well, what we could have done is gone over here to the 50L6. Now here's the socket on the 50L6, and you'll notice that there is another loose terminal right there with nothing soldered to it. That is pin 1. There's the key to the tube. Let me see if I can get a lamp over here, shine a little, maybe it'll help, maybe it won't, I don't know. Sometimes you turn on a lamp, it doesn't do anything. Alright, there's the key right there on the tube, alright? That's pin 1, and that's our loose terminal. I mean, our loose solder point on the bottom of that socket. Now, what does pin 1 go to? Let's take a look at that. Now, here's the 50L6, and we're going to go down and take a look at the 50L6 GT, which means glass tube, and we're going to go down here to pin 1 on the 50L6, and what do we have? Well, you'll see pin 1 is connected to nothing again. 0, no connection inside the tube. It's just a dead pin, okay? So what we could have done, all these wires that I connected here to pin 1, had this thing already been, you know, filled up with wires already by, you know, use at the factory, I could have taken these wires, put, you know, extensions on them, made them longer, you know, spliced some wires on them, and I could have connected them to right here. Just connect them all to that terminal right there. Alright, and then run a wire all the way back down here along the bottom of the chassis, all the way down, then brought it up and soldered it there. Same as what we have here, except this pin is now located over there. So you do have other options, you know. If you have one that's not, it doesn't have to be on the exact same tube socket. As long as you know it's not being used and there's nothing there at all, and that pin is connected to nothing, it's essentially just a piece of metal sticking up with holes in it that you can use as a terminal point. The factories did it all the time. I'll show you one right here on that tube we just fixed. As you'll see right here, there is, let me see if I can get it, make it look real good here so you can see it. There we go. See that pin right there? Totally empty. There's no tube pin coming down through that. But if we zoom in here, you'll see that there are wires soldered to it. They use this one as a terminal point to run wires, and they'll put components on it and everything. It doesn't matter. It's an unused pin. Why not use it? Well, that's it, guys. I hope that helped a little bit. Sorry about the little screw up in the last video. It's going to happen again. And you might as well get ready for it. It happens all the time, especially the older you get, you know. But I'm not going to tolerate a bunch of weirdos poking in here telling me, you know, trying to catch me on it, trying to show everybody how brilliant they are. Yeah, you know, I'm just going to block them. I'm going to block them, and I'm going to delete their ignorant comments, and that's going to be it. And if they don't like it, tough. Okay? So we're trying to teach something here guys that want to argue all the time or get into some big long debate or long drawn out discussion about how smart they are and how dumb I am or anyone else is. We don't need them, don't want them, they can go away and never come back. I do my best to make that happen. I consider it taking out the YouTube trash, okay? All right, that's it. Until next time, hope you learned something. This is John. Well, there is one other thing I got to cover. I couldn't believe it. I meant to cover it and I forgot. This metal tube right here, all metal tubes like this that have metal casings, pin 1 on those metal tubes is always grounded. Okay, right here, pin 1 will always be grounded. There's the key and there's pin 1. Pin 1 is connected to the shield, and anything that hits it, of course, will go down to pin 1 and then down to ground. That's the purpose of a shield, to take away spurious signals and all kinds of crap, inter-tube capacitances and all this other jazz, all kinds of, it's kind of a neat thing. Underneath that metal, by the way, is glass. All they did was take metal and stick it over the top of glass. Anyway, if you're going to utilize pin 1, now the glass tubes don't have pin 1 grounded. They just don't, okay? However, some radio manufacturers were pretty smart. They went ahead and grounded pin 1 on the glass tubes also, just in case someday you decide to change them out with available metal tubes. Well, in that case, the metal tubes got to go in and pin 1 will need to be grounded. So they went ahead and grounded them, those pin 1s, even though the glass tubes didn't need it, didn't require it. I've seen a couple of radios like that. I thought it was pretty neat. You know, I didn't have to worry about grounding pin 1. I ordered some tubes and all they had was the metal. Is the metal okay? Yeah, the metal's okay. And then I went underneath to make sure pin 1 was grounded. They were already grounded. I said, "Well, this is great." You know, a tube came in. I just went ahead and plugged it in the hole. So be careful. You know, when you're you always have to check your tube manuals and your tube schematics and drawings to make sure that the tube pin you're using is not pin 1 that will be used with a metal tube. Okay, you have to, if it's glass, it has to stay glass. Okay, if you decide to jumper across like I showed you. And now I could have taken a terminal strip. And one more thing I probably should have told you. Might as well talk it out now, get it out of the way. I could have taken a terminal strip and put it in here anywhere and put all those wires to a terminal on the terminal strip and then run a wire from the terminal strip down to pin 2 on that socket right there. That was one way of doing it, but that would have required me to do some more unsoldering and things, and I really didn't want to do that. But I could have done that. I could have located the terminal strip, I don't know, over here somewhere, maybe over here somewhere, who knows, you know, find a spot and make it happen. All I needed was a junction point, okay? And if, you know, if it ever came down to the point where I absolutely needed another junction point and I didn't have any, you could always unsolder this, you know, hook it to a terminal strip and then run the wires to that and solder them all together. You know, there's all kinds of scenarios that could pop up. Until next time again, this is John.